Today we will have a lecture on resolution of forces. In previous lectures, we have solved the problem related with grid, in which different forces were acting on a grid. We have also calculated x and y intercept, the resultant, whether it is in first, second, third, or fourth quadrant, and what is x and y intercept of the resultant. So already in previous lectures we have gone through the problem related with the grid. So again some more numericals in today's lecture. We will solve some more numericals related with the grid. First of all, I will read the problem. Find resultant and its location of the force system shown in figure. The grid is 1 unit. That means what is the size of one block in this grid? One square block in this grid, it is having a size of 1 by 1. That means along x direction it is having 1, whether it may be a centimeters or meter. So 1 is the unit of the grid, one box size of the grid. Okay? The grid is 1 unit along x and y directions. Okay? So that means the size of one block in this grid is 1. So how many, what is the total size of this grid? So 1, 2, 3, 4, 5, 6, 7. That means along x direction, 7, that is in meters. Suppose we are considering all the dimensions are in meters. So 7 meter it is having a dimension in, that is the distance in x direction. Whereas in y directions, 1, 2, 3, 4, 5, 6, 7. So 7 by 7 is the total size of this grid. 7 meters by 7 meter is the total size of the grid. So while solving the problem related with the grid, first we have to identify what is the size of a single block. We have to find out the size of a single block. Depending upon that size of the single block, it will be given in the question. So depending upon that size of single block, the total size of the grid we can find out, and depending upon that, the different forces which are acting on this grid. Okay, so here there are 4 different forces which has been acting in different directions. 15 Newton, it has been acting in downward directions at a particular point which is having some x and y distance. Again 300 Newton is also acting, which is again it has been acting at a point, it is having some x and y distance. So here the 300 Newtons, it is having x distance as 2 meters. What about the y distance of this 300 Newtons? So 1, 2, 3, 4, 5 meters is the y distance of this 300 Newtons. So in similar manner we can find out the distance of all the forces along x and y directions. Okay? So we have to use the principle of transmissibility while finding out the forces, or while finding out the x and y intercept, because principle of transmissibility plays an important role while finding out the x and y intercept. So here we have to find out the x and y intercept of the resultant also. Okay. For this finding out, in order to find out x and y intercept of the resultant, we have to use the principle of transmissibility, and also we have to use that is the theorem, Varignon's theorem. Okay. So with the help of Varignon's theorem we can find out x and y intercept, and with the help of principle of transmissibility we can have a moment. We have to find out the moment by using the principle of transmissibility. Okay. So you can refer the previous lectures regarding the principle of transmissibility and Varignon's theorem. Okay. So in short, we will cover in today's lectures also how to find out the forces by the principle of transmissibility, and how to use, or in what way we can use the Varignon's theorem. Here 300 Newton, it is acting inclined. So it is making an angle of, first we will give the names to these angles. So 300 Newtons, suppose we are calling this as theta 1. So it is making always inclined force, it is to be resolved along, or the angle made with horizontal x-axis. Okay, we can find out, or we can take along y-axis also, but it is easier to solve. So therefore we will always convert this inclined force, or we will resolve this inclined force, or the angle made by this inclined force we will take along the with respect to x. Okay. So this 300 Newtons, we are making, it is making an angle of theta 1 with respect to x. Again this 100 Newton, again it is having, we can make along with y, along with x. So we will have with x, so we will take this as theta 2. We will call this as theta 2. Again third force is 150 Newton. Again this along x directions with respect to x, we will call this as theta 3. So in this way we have decided the angle made by this 300 Newton is theta 1. We have given the name as theta 1. For this 100 Newton we have given with along with x directions, x intercept, that is theta 2, and 150 Newton we have given this as theta 3. Angle made by this 150 Newton is theta 3 with x axis. All the angles it has been making along with the x axis. Okay. After finding out this, we have to find out the angles. So how to find out the angles? So theta 1, theta 2 and theta 3. So we can use the tan theta formula. In order to find out the angles, we will use the formula as tan theta. So first we will find out of tan of theta 1, then tan theta 2 and tan of theta 3, one by one. So I am writing down here because a limited space is available, therefore I am starting the solution from this part. So you can start from this this here also. So we will find out first of tan of theta 1. What is the formula for tan theta? Tan theta is nothing but opposite upon adjacent. Opposite upon adjacent. So here opposite side in this case for theta 1 is opposite is this vertical side is opposite side. So how many blocks are there? 2 blocks are there. So here opposite side is 2. And what about the adjacent side? If it is 90 degree, this dotted line is the hypotenuse, then adjacent side will be this horizontal x direction is the adjacent side. So 1, 2, 3, 4, 5. So it is 5 meters. Okay. So theta 1 is equals to tan inverse of 2 by 5. Tan inverse of 2 by 5. The angle made by this is nothing but 2 by 5. So it comes to be 21.8 degrees. You can find out the angles also with the help of the calculator. You can calculate the angles. So it comes to be 21.8 degrees. So theta 1 it comes to be 21.8 degrees. Okay. Similar way we can find out the angle theta 2 also. So I am writing down theta 2 here. So same concept is used. So theta 2 is equals to, directly I am finding out this tan inverse of opposite upon adjacent. The opposite side for this theta 2 is this triangle. This is the end point of this force. So we will have this opposite side as 1, 2, 3. So 3 meters is the opposite side. What about the adjacent side? Adjacent side is 1, 2, 3. So 3 by 3, 3 is opposite and adjacent, both are 3. So how much is theta 2? Theta 2 it comes to be 45 degrees. It comes to be 45 degrees. Same way theta 3 is equals to tan inverse of, again the same formula, opposite upon adjacent for theta 3. Opposite side in this case is 2. So 2, adjacent side in this case is 3. So 2 by 3 it comes to be 33.69. So it comes to be 33.69. 33.69 degrees. Okay. So in this way we have calculated all the angles. The theta 1 is 21.8 degrees, theta 2 is 45 degrees, theta 3 is 33.69 degrees. So we can highlight this. This is theta 1, theta 2, and this part is theta 3. Okay. After finding out the angles, first we have to resolve along x and y directions. So we will resolve all the forces along x and y directions. So 50 Newton is vertical. There is no need to resolve this 50 Newtons. Theta 1, we can resolve this 300 by principle of transmissibility. We can resolve at this point also, at this point also. That means we can resolve the force of 300 Newton at this point also, this point also. Okay. But for convenience, as it is mentioned at the corner point of this grid, so we will resolve at this point. Okay. So for convenience, you can resolve at starting point or end point. That is the intensity will be same, its effect will be same. You can resolve along at the tip or at the starting point or at the end point. Okay. So theta 1 angle made with the horizontal x-axis, therefore it comes to be cos theta will be, x component will be cos theta. So 300 cos of theta 1. Okay. Then vertical component is 300 sin of theta 1. What about theta 2? Theta 2 is again this force will be resolved along these directions. So here there will be a force along these directions. So here and this force. So this x component will be cos theta. So 100 cos of theta 2, and this will be 100 sine of theta 2. So we have resolved at the end point. What about theta 3? Again we can resolve this along these two directions. Again x component will be 150 cos of theta 3, and this will be 150 sine of theta 3. So we have resolved the forces along x and y directions. So these are the three inclined forces were there. So we have resolved all the three forces. Next is we have to find out the x and y component. Okay, so we will find out the x and y component for these forces. So summation of fx and summation of fy. So summation of all horizontal components. So fx is equals to all x components. Fx is equals to, one by one we will find out x component of theta 1, theta 2, theta 3. That means 300 newtons, 100 newton and 150 newton. So 300 newton, what is the x component for this? So 300 cos theta 1, it is moving right side, so therefore it is positive. So plus 300 cos of theta 1. Theta 1 is directly I am keeping the angle, so 21.8 degrees. Next force is theta 2, second force. What is the x component for this? Yes, 100 cos of theta 2 is the x component, but it is moving left side, therefore minus 100 cos of theta 2. So here theta 2 is 100 cos of theta 2 is 45 degrees. Next, again x component for this 150 newtons, it is moving right side, plus 150 cos of 33.69 degrees. So in this way, what is summation of fx after calculating or after finding out the value? It comes to be 332.69 newton. The fx, it comes to be 332.69. So summation of all x component, it comes to be 332.69. Same way we can find out the y component also. Okay, y component of all the forces. The first is the downward force is acting. So this force is the y force